Hello, welcome to another quick maths tutorial in which I'll be explaining logarithms. So if I write 2 to the power of x and I put it equal to 8, you'll notice this is in an exponential form, and usually I'd be told if you knew the power you'd be able to work out what the answer was, in this case 8, and if I told you 8 and the power you'd be able to work out 2 using the x root. But you wouldn't really know how to work out the power at the minute. So to work out x, we have this function called the logarithm, and what we say is we read it as log base 2 of 8. So 2 is what's called the base, and 8 is what's called the argument. And that simply type this into a calculator, and it will tell you the power. So calculator should have this as standard. If it doesn't say what the base is, doesn't let you write in subscript, usually it means the base is 10. That's a very common base. It's good for standard form. Binary usually uses a base 2 because they do things powers of 2. So log base 2 of 8 would spit out 3. There's also some rules involving logarithms with similar bases, just like there's index laws, because indexes are powers, and logarithms I recommend to read them as powers as well, because they are put equal to powers to solve them. So with that, we can actually, using this index law, that x to the a times x to the b is equal to x to the a plus b. Well, sorry about that. We know a would be equal to log base x of x to the a, because it is the power raised x to get to x to the a. That makes sense. And the same with b. So we're just using from what we know from the statement what a and b are, and also a plus b. It should be equal to log base x of a plus b. Now from this, what we can say is that when the powers add together like this, the arguments times together. Because basically x to the a times x to the b is x to the a plus b, so the arguments are times together, but the logs have added. So this is what we can derive from the exponential rule we already know, the index law we already know. And just like as when we times and we add the powers in index laws, when we divide, we subtract the powers. So from that, we can also say the same thing with logs. So because logs are the powers, essentially, just written differently, we can say that when the powers are subtracted, it's when the arguments are being divided. So we'll see log base x of a minus log base x of b should be log base x of a over b. And there's one more log rule I have for you. This is a little different, and it makes more sense if you understand powers. Again, so log base x of a to the k, so the argument's got power in it. Well, we can take the k as a coefficient, take it out, and so it's equal to k times log base x of a. We know this from just standard. We're raising the whole thing to k. Technically, we're multiplying log, which is a power, by k. And finally, you might see ln. All that means is we read it as natural log, and this is basically log base e, where e is Euler's number, which is roughly 2.7. So because that's used a lot in like pure math, like calculus. So don't be surprised if you see ln of x. And that's all there really is on logs. So thanks for watching.